All right, so next we're gonna go the opposite direction and look at our sum to product identity. So basically just the reverse of what we were doing in the last video. So we have 4 more identities right here. Okay, once again, you do not have to memorize these, you just have to know how to use them. And what these do is they take us from either a sum or a difference of sines and cosines, and they can rewrite them as a product. Okay, these would be useful potentially in a situation where maybe you're solving an equation. It's easier to solve an equation if it's in factored form or if it's multiplied than if it's added or subtracted. So that would be one potential use of these equations. But we're going to look at them to just kind of simplify some expressions again and to evaluate some of our trig functions. Okay, so example 3 here says express each sum or difference as a product of sines or cosines. So just using these identities to rewrite them as a product. So we have sine of 4 theta plus sine of 2 theta. So sine plus a sine. I'm going to be using our top formula here. And I am just going to label my angles as alpha and beta. So 4 theta is alpha, 2 theta is beta. And we're just going to plug it in. This is going to be 2 sine of 4 theta plus 2 theta divided by 2 times the cosine of 4 theta plus 2 theta. Sorry, 4 theta minus 2 theta divided by 2. Okay, combine like terms. So 2 sine. All right, so this would be 6 theta over 2, which is 3 theta. And then this would be 2 theta over 2, which is theta. So 2 sine of 3 theta times the cosine of theta. There's no negative angles to worry about, so this is our final answer. Okay. All right, example 3b, we have cosine of theta plus cosine of 3 theta. So cosine plus cosine. I'm going to be using this third identity right here, cosine of alpha plus cosine of beta. So I'm going to label my angles as alpha and beta and just substitute them into our identity. So we'll have 2 times the cosine of theta plus 3 theta all over 2 times the cosine of theta minus 3 theta all over 2. Simplify. This would be cosine of 4 theta over 2, which would be a 2 theta, times the cosine of theta minus 3 theta, which is a negative 2 theta over 2. So that becomes negative theta. Okay. All right, now here we do have to simplify a little further. We don't want to leave our answers with negative angles, but again, we have a cosine, and just like we said above, we know that cosine is an even function. So cosine of negative theta just turns into cosine of positive theta. So this is 2 cosine of 2 theta times the cosine of theta. So that is our final answer. All right, we can again use these to evaluate our trig functions. So in this case, we're looking at sine of 255 degrees minus the sine of 15 degrees. So sine minus sine. We are going to be using the second formula, sine of alpha minus sine of beta. So I'm going to label my angles as alpha and beta, and then we can plug them into our identity. So this is going to be 2 sine of 255 minus 15 all over 2 times the cosine of 255 plus 15 all over 2. Okay, so then simplify here. We would have 2 sine of 120 degrees times the cosine of 135 degrees. All right, so 120 and 135 are both unit circle angles, so we can just plug in our values. So sine of 120 is root 3 over 2. cosine of 135 is negative root 2 over 2, and then just multiply across. So I'm going to go ahead and just reduce this before I multiply, cancel one of those 2's out. So you get negative square root of 6 divided by 2 as our final answer. All right, last thing I want to show you guys with these is some more verifying of identities. It's always good to come back around to this because this is a tricky topic. So if we're verifying our identities here, our first one is cosine of theta plus cosine of 3 theta divided by 2 cosine of 2 theta is equal to cosine of theta. So trying to verify this identity, as usual, I'm going to start on the more complicated side, which would be our left-hand side on this one. Okay, so thinking about how we can approach this, given that we're looking at our product to sum and sum to product identities, that's probably what we want to be looking at here. So if we take a look at that numerator, we have a cosine plus a cosine. So I'm going to go ahead and think about using this third sum to product identity, the cosine of alpha plus the cosine of beta, in order to switch that sum to a product. Okay, so I'm going to think about this as my alpha and my beta. And again, I'm going to use the sum to product formula in order to change this to a product. So this would be 2 cosine of theta plus 3 theta over 2 times the cosine of theta minus 3 theta over 2. I'm just going to leave the denominator alone for now. Okay, so if we simplify these, we would get 2 cosine of 2 theta times the cosine of negative theta divided by 2 cosine of 2 theta. Well, notice we have a 2 cosine of 2 theta in both the top and the bottom. So the 2's will cancel, the cosine of 2 theta will cancel, and we're left with cosine of negative theta. But once again, because we know that cosine is an even function, this just turns into cosine of positive theta, which if we look back is exactly what we wanted. All right, guys, I'm going to leave example 5B for you to try on your own, but of course, as usual, I will post the solution up on Blackboard. All right, guys, so that is the end of Unit 3. So you should now start working on the homework for this section and then start reviewing for the Unit 3 test.